This meeting is being recorded.
Am I audible? Am I audible?
This meeting is being recorded.
Okay, screen is visible.
Yes, sir.
Okay, so um, in last lecture, what we have studied regarding the different types of MOSFET, its working principle, circuit diagram, right? Then its construction. Okay, so the point that you should remember is depletion type MOSFET will have a negative gate to source voltage, and enhancement type MOSFET will have a positive gate to source voltage. See, one more point I want to tell you is uh, if you look at the VI characteristics of depletion type MOSFET, you will come to know that actually that depletion type MOSFET can be act as an enhancement type MOSFET once you have increase its voltage at above zero level. That same MOSFET can be act as a enhancement type MOSFET when you increase that voltage above 0 volt. Okay, so basically the depletion type MOSFET can be called as DE MOSFET. Means what? It can act as a enhancement type MOSFET also and depletion type MOSFET also. Okay, and that's why it is called as normally on MOSFET, depletion type. And talking about the enhancement type, which is referred as normally off MOSFET, because at uh, zero level or zero voltage level there is no current. Okay, that's why it's a normally off MOSFET. And whatever the positive voltage we have applied to the enhancement type, it's a positive voltage, gate voltage. Okay, in case of depletion type, whatever the gate voltage we have applied is a negative type. And depletion type MOSFET can be act as a enhancement also if you uh, gate voltage increases above 0 volt. It is acts as a enhancement type. Okay, that point you should remember. Now this is what the summary of different types of MOSFET, right? Actually we have studied this, but to have a more clarity, you can just remember this table. Okay, this could be a helpful to summarize you what are different condition for what are different types of MOSFET. Okay, so first you have a N channel D MOSFET. As you know, D stands for depletion MOSFET, right? And E stands for enhancement type MOSFET. Okay, so you should clear with this notation. So first is a N channel D MOSFET. So whenever VGS is a positive, it's on. When VGS is negative, it's on. And when VGS is negative, it's a off. Okay, regarding N channel D MOSFET, these are the conditions. Same P channel depletion MOSFET. When VGS is positive, it's off. When VGS is 0, it's on. And when VGS is negative, still it's on. Means it can work into a negative region also. Now here that you should remember, for VGS 0, this enhanced both depletion type MOSFET is on. right? And that's why it is called as normally on MOSFET. And when you increase VGS depending upon type of MOSFET, it can be act as a enhancement type MOSFET. This depletion type MOSFET, depending upon the it's whether it's N channel or P channel, when you increase the voltage, it will act as a enhancement type. For example, for a N channel, if you increase this VGS above zero value, it's on, right? That means what? Now it you can say it could be acting as a enhancement type MOSFET. Similarly, for this P channel D MOSFET, if you reduce voltage below this negative, it will it will act as a, or it will be on. That means at this region it will act as a enhancement type MOSFET. And for both cases, in a VGS 0 it is on. Okay, now coming to the enhancement MOSFET, E MOSFET. Okay, this N channel E MOSFET, for VGS positive, of course, it is on. For VGS 0, it's a off, and VGS negative, it's a off. It is N channel E MOSFET, and our in this subject we will be more focusing on this N channel enhancement MOSFET, right? Similarly, with this P channel E MOSFET, VGS positive, off, VGS 0, off, VGS negative, it's on. Okay, VGS negative, it's on. So you have to remember this table so that you can clearly understood what will happen when VGS is positive, what will happen when VGS is 0, and what will happen with VGS is uh, negative. Okay, so it's a on off here, on off here, off on. And you have to first start with the N channel D MOSFET, then P channel D MOSFET, then N channel E MOSFET, P channel E MOSFET. Okay, first N channel, then P channel. You have to remember this thing, first D MOSFET, then E MOSFET. So you can by heart this table very uh, easily. Okay, so this is about the different types of MOSFET, and on which gate voltage it will be off or on. Okay, so this table summarizes the different types of MOSFET and its what we can say on and off characteristics. Next part is symbols. Okay, symbols for various types of MOSFET. So I think this part also you have already studied in your secondary CAD subject. This may be a repetition for you. So symbols for different types of MOSFET is, first one is a N channel enhancement type MOSFET. Okay, so as it's a N channel, that arrow indicates towards the gate, right? Arrow indicates towards the gate, and the current flow shows is away from gate. That's the N channel. And one more thing, at this enhancement type, it shows the cut into the gate region. That shows it's the enhancement type MOSFET. In case of depletion type, there is a thorough solid line, but in case of this enhancement type, there is a cut solid line. Okay, so from this what we can say, from this symbol you can easily identify this is a N channel depletion type. So as it's a N channel, arrow is towards the gate, and this gate line is solid. It's a N channel depletion type. Now what about P channel enhancement type? So as it's a P channel, arrow is away from the gate, and this solid line is of cut, right? It has two cuts. That indicates it's an enhancement type, and this arrow indicates it's a P channel. Similarly, for a P channel depletion type MOSFET, arrow indicate it's always away, and as it's a depletion type, so it's a solid line, entire solid line. So these four symbols that you should remember, because it's a mathematical representation, sorry, symbolical representation of MOSFET. Now see, this diagram again summarizes the N channel D MOSFET, P channel D MOSFET, right? Following at the bottom side, you have a N channel E MOSFET and P channel E MOSFET. Okay, so already this diagram and its working that we have already discussed. Okay, now next part of our syllabus is the accumulation, mode, depletion mode, and inversion mode. Okay. Now, what do you mean by accumulation mode? What do you mean by depletion mode? And what do you mean by inversion mode in case of MOSFET? Okay. So the behavior of a MOS transistor, right? It can be understood by the examination, by examining isolated MOS structure, that is with SiO2 layer, with gate and body, right? But no source or drain. So basically, at to understand this accumulation, depletion, and inversion mode, we have to analyze MOSFET, assuming that, right, it has only isolated MOS structure, right? So coming talking about the first, that is accumulation mode. Now what will happen in this accumulation mode? So first, you have this uh, SiO2 insulator layer, silicon dioxide insulator layer, VGS is less than 0. Now what happens? So this, in case of accumulation mode, a negative voltage is applied to the gate. Okay. Gate is having the negative voltage. So there is a negative charge on the gate. The mobile positive charged, that means holes, are attracted to the region beneath the gate. This is called as accumulation mode. Means what? When we apply a negative voltage to the gate, see, uh, for your easy understanding, you can just assume the MOS structure as a two parallel plate capacitance, right? MOS structure as a two parallel plate capacitance. At one is at a drain and one is at a source. So in between, or the one plate becomes the positive, but obvious, it will attracts the electrons from the other plate, that forms the conduction, or that forms the channel. So you can correlate this MOS structure easily with two parallel plate capacitance. Okay. For your simplicity of understanding. Okay, so what happens in this accumulation mode? So in this accumulation mode, whatever the negative voltage that you have applied, okay, it will it will create a negative charge on the gate, and the holes are nothing but what? Positively charged carriers, right? So this mobile positive charges, that means holes, are attracted to that region, that means towards the gate, right? And it will accumulate there. This type of action, or this type of what we can say working, is called as accumulation mode, accumulation of the charges. This is the accumulation mode. Now, next one is a depletion mode. Okay, what happens in a depletion region? So here is the condition. Now, gate voltage is still less than 0, but it is less than threshold voltage also. Now, what happen in this depletion mode? A small positive voltage is applied to the gate, a very small positive voltage that we have applied to the gate now, resulting in some positive charges on gate. Right, until now we have applied the negative charge on gate. Now we have applied a positive charge on gate. So now on a gate you have a positive charge. The holes in the body are repelled from the region directly beneath the gate. Okay, as it's now positively charged. Okay, now the holes are not no more attracting towards that gate terminal. Now the gate will repel that holes away from the gate, right? That forms the depletion region below the gate terminal. In accumulation mode, what happens? First, as the gate is a negatively charged, it attracts the electrons, right? It attracts the holes, positively charged carriers beneath the gate. That's the accumulation region. In accumulation region, gate is negatively charged, so it attracts the positive charge, that means holes beneath the gate. That forms the accumulation mode, or accumulation of, you can say accumulation of uh, uh, holes beneath the gate. Beneath means त्याच्या खाली असा अर्थाने. In depletion mode, what happens? Okay, now we have charged the gate with the positive voltage, right? We have charged, or we have applied, in a simple language I will explain, we have applied now the positive voltage on a gate. Now what happens, that positive voltage, whatever the holes that already accumulated beneath the gate, after applying positive voltage, it will goes away from the gate, right? Because positive charge will repel each other, right? So whatever the holes that are accumulated beneath the gate terminal because of that negative voltage applied to the gate, now we have changed the voltage to the positive voltage at the gate, so that all holes that are already accumulated because of the positive voltage now goes away from the gate, right? And or you can say it will get repelled from the region of that gate which are already accumulated, and this type of action is called as depletion region formation, right? This type of action is called as depletion region formation below the gate level. Now the holes are repelled from the, and that forms the depletion region. This is the depletion region. Now next is a inversion mode. Next is a inversion mode. Now what happens in this, what happened with this inversion mode? So now we have increased that positive voltage to some next extent. Okay, now we have increased that gate voltage above threshold voltage. Okay, in depletion mode, what we did, we have just increased voltage above zero. We have just increased voltage above zero, but now we have increased that positive voltage greater than threshold voltage, right? We have increased that positive voltage greater than threshold voltage. Okay, now what happens when the higher positive potential or voltage, right, exceeding the threshold value applied to the gate, now what happens, that attracting more positive charges to the gate, the holes are repelled further and further, and some free electrons in the body are attracted to the region beneath the gate. Now, when you increase the positive voltage, right, that holes, right, in a depletion region which are already repelled, it will get more repelled from the gate terminal, and whatever the free electrons that are available, that will get attracted. म्हणजे होल्स लांब जाणार आहेत आणि इलेक्ट्रॉन्स आता गेटकडे येणार आहेत. नाउ दॅट काइंड ऑफ ऍक्शन इज कॉल्ड ॲज इन्व्हर्जन मोड, right? That kind of action is called as inversion mode. Now this conduction layer of electrons in the p-type body is called as inversion layer, right? This conduction layer of electrons which are now gathered or accumulated beneath the gate, and holes are more repelled away from the gate, this action is nothing but the inversion mode of MOSFET or MOS transistor, you can say. Clear with this? Means what happens in accumulation mode? In accumulation mode, first we apply negative voltage to the gate. Okay, as gate is negative, as we apply negative voltage, that means what, gate is now negatively charged. Then it will attract the holes towards that negative charge. Now we have accumulation of holes beneath the gate terminal. This is accumulation mode. Now we have increased the voltage just above zero. That means we have now applied the positive voltage to the gate. Okay, just above 0 volt, but it's a positive. Now what will happen, as we have applied the positive voltage to the gate, now whatever that holes, those are already accumulated, right? Those are repelled away from that uh, gate, right? Or that will goes away because of the same charge on the gate. That forms the depletion mode. And still you further increase that positive voltage, maybe a greater than threshold voltage. Now that holes are still again will go further away, and whatever the free electrons will start attracted towards that positive gate region in case of inversion mode. And this action of repelling the holes away and attracting the electrons is called as inversion mode. is called as inversion mode. All of you clear with this?
Yes, sir.
Okay. Now this is what the again diagrammatical representation of the same accumulation mode, depletion mode, and inversion mode, right? And its conditions are given. So you know already in cutoff region there is no channel formation, only IDS is equal to 0. That means it's only accumulation, there is no conduction. In linear region what happens, right? So that holes will get repelled, and electrons will start after that. That means after depletion region it will go to the inversion region and some current will start flowing. That means here you will get some value of IDS that is linearly proportional with the VDS and VGS. This is the linear region, or you can say ohmic region. Now still you increase that positive voltage, again the condition will reach that there is a no longer channel existence. Okay, and that condition is called as pinch off condition. And as the pinch off condition, now this IDS will remain constant. That means it is now independent of VDS. That means you increase now VDS, IDS will not increase, it will remain constant at the after this pinch off condition. And it is happens in a saturation region, right? And in this saturation region we already prefer to use this MOSFET as a amplifier in this saturation region. Okay, what happens in this saturation region, you IDS will be independent of VDS. Now doesn't matter uh, how much VDS you increased, IDS will remain constant, because now there is a pinch of condition. That means there is a very little path for the electrons to cross that channel, because channel gets narrowed down, and that's condition is called as pinch off. Now there is no further increase in current though you increase the voltage, and that's happen in a saturation region. Means in saturation region IDS will remain constant at certain maximum value, and VDS is irrespective and it is independent on VDS. That means now if you increase VDS further, but IDS will not change, it will remain constant, right? IDS will remain constant at its maximum value, and it of course it is independent of ADS now. This happens in a saturation region. Okay, so these are the conditions for MOSFET cutoff, linear or ohmic. This linear can be referred as ohmic, and third region is a saturation region. Okay, समजलंय का सगळ्यांना?
Yes, sir.
Okay, fine. uh, so now for now we will stop here. We have again one more lecture today, so we will continue with the MOS design equations in that lecture. Okay, for now we will stop here. If you have any query or doubt, you can raise your doubt now.
No doubt, sir.